welcome to day 28 of the 30-day coding challenge here from CS and Math. We were going to look at that geometry example more today if you were around yesterday, but I don't know, we're running out of days and we wanted to get into probability, so we decided to do that. And within this conversation, we're going to be talking about how to do some randomization in order to basically simulate events and assigning the values, assigning those random integers, we're going to call them, to values or results that you want. And these involve a lot of conditional logic. So let's get in and hop right to it. We'll do, we're going to do two examples. We're definitely going to do dice. We're going to start with a coin first. It's simple. It'll lay the basics out, and then we'll convert that over to at least some dice rolling today. So we'll say coin and dice problems. All right, so get set up and let's get started. Okay, so obviously for flip, which is the most basic probability, because it's always this two choices, excuse me, or two results. Let's initiate heads and tails as variables then, and just initiate them both at. We haven't flipped anything, so there's no heads or no tails. But how in the world are you going to simulate a flip happening, something that is going to give you 50-50 results? And that's where programming languages all come with some type of simulation like that. So let's, we could call it something generic like result, but let's say it's called flip. And flip is going to be equal to a random number. So if you try to type something like random, notice that it's not going to like that. So Python, there's no, blow this up for you guys. There's no available randomization. You have to actually import the random module. So if we say random dot, this actually is a command called random integer, and you could do 0 or 1. I'm going to do 1 up to 2. So that's going to say it can either be 1 or anywhere in between up to 2. If you don't give it any decimals, it's going to specify that these are whole numbers, which is all we're going to do today. And should be really all you need to do for most classes. So then if I did, for example, print flip and run this, notice how it's printing a 1. The random number that was generated was a 1. If I run it again, right, if I'm running it, it's flipping between 1s and 2s. So these are like our flips of the coin, even though we don't have a physical coin. What's nice about some languages, like let's say Scratch is a block-based language, where you're programming objects called sprites, you could actually get a flip occurring in the screen pretty easy. A little harder to get it happening here in Python, but this is the same thing. Okay, so hopefully that's making sense. Now what we want to do is actually, instead of printing 1s and 2s, we want to print heads or tails and keep track of them and count them. So in order to do that, let's do an if-then conditional, like for the logic. So what we've done to start with is we've imported the random package, we've initiated the values at 0, but now we want to start tallying them every time we get them. So if flip is the name of our result, flip, if that's equal to, remember you need a double equals to, because we're not assigning flip a value, we're checking for equivalency. If it's equal to 1, let's tell that's going to be heads. So we'd say heads plus equals, let's just do an incrementing by 1. So every time you check and it's equal to a 1, we're going to increment the heads up by 1. And for now, let's just print. We don't have to print there. So let's just say else. So if this top condition is not met, that means that it's a 2, obviously in this case, because there's only 2 choices. We are going to say else tails plus equals 1. All right, and then we are going to print. Let's print the heads. So if I run this, no heads. Notice how eventually there was a heads printed. Okay, so then we could get a bunch of these, and let me just delete that off. We could get a bunch of these happening by just looping it, right? So if I did for I in range 10, let's say we wanted to do 10 flips, and then I would remember indent all of this in. And then instead of printing heads, let's go ahead and just print the flip. So the flip, remember, is either going to be a 1 or a 2, and it should print 10 of these. So if I put this up and run, notice, oh, interesting. So we're just getting all tails. So that's interesting. So obviously when we rolled this, this was the roll, right? And maybe I could even comment that. And we didn't get the roll here because in this loop we never re-rolled. Or, sorry, I'm getting ahead of myself. This is the flip. And we never flipped. So if I take this and cut it out, I need to, before excuse me, before each if then conditional, I need to do a reflip. So I run this, and now we're getting different results. Okay, and then we just want to tally them. So we already have them tallied, right? So then at the end, if we're printing the flips, we could say, we could also print these quantities. So maybe to do that, let's type in print. Let's actually make some language in there. So I'm going to type heads colon, and then I would do plus, and we have to convert the actual variable heads to a string, so that adds this string to that, and then I could take that and basically model that same structure for tails, and instead of having heads here, I would say tails here. Okay, so now if we run this, notice at the end it tells you how many of each. If I just run these a couple times, you're noticing that it comes out to be pretty fair. Now I don't actually have to print out all the roll or all the flips, so maybe I turn that off. I comment that line out, and now I run this, and it tells me out of the 10 how many heads and tails. Okay, so what if we wanted to do more? Because we do want to test and see, is this a fair thing? Is this coming out to be closer to what we said, 50-50? And if you run it here, the 100, notice how fast that happens, right? And kids instinctively want to just keep bumping that number up to as big as they can. So let's just do, what, 1,000,000? 1,001, 1,002, and okay, so about a little over 2 seconds, you can see that it is coming out to be 1,000,000 flips like that, right? And so that's kind of the power of the simulation here, and it is coming out to be close to 50-50. So let's abstract that out just a little bit into a function. So I'm going to say, okay, let's make this into a definition. Now we'll make this a little bit smaller. So let's say I want to define this as like coin flips or something like that. And I want it to take in a number of trials for a parameter. And then I'm going to actually indent all of this to that definition. So whatever the trials we tell it would go in here as trials, right? That's how many times we want it to reoccur. We've got this kind of commented out. We don't actually want to print every individual roll necessarily because we have the totaling at the end. So this basic structure right here captures our, oh, when we have to call the function now. So we abstracted it out so we could at any point do some random flipping. So I do coin flips, and I would, let's say, run that 100 times again. And if we run this, right, yeah, again, so we run in this problem where it's redefining, or what would I say, reassigning is a better word, values to both heads and tails. So if you do these functions, you have to make the heads and the tails variables global so that they can use them elsewhere. So now if I run these, again, you're finding that this function executes. So to finish up, this is pretty good for today. This is really what I wanted to do. Now, what if I said I wanted to change this model that we have here from coins, like we have right here, to dice? If I said I want you to do 100 rolls of a die, and I want you to tell me how many were odd and how many were even. See if you can't think about how you change that code. Yeah, hopefully you said the structures are the same. Maybe you said instead of like 1 through 2, or 1 or 2, just two choices, you do 1 through 6, and then instead of a flip, this would be a roll. And then instead of heads, you could do odd, even. Now certain odds, maybe I'll do plural here, odds and evens. So notice that those are obviously going to all change. These wouldn't be coin flips. These would now be dice rolls. This is going to be odds. We'll do first. Evens for item in range trials. So we still have trials. We instead of a flip now would have so the roll. But what I'm trying to show here is that the structures don't change, just the words. So you could generically put those instead of odds and evens or heads or tails. You could, if you were trying to do multiple things, just call this result 1, or sorry, satisfy 1, satisfy 2, or something like that. You know, something just general, and then instead of rolls or flips, you could just call those results, and then make it more generic so it could fit anything. So if the roll equals, it can't just be equivalency here. We'd have to use what's called mod or modulo. So if rolls %2 means mod 2, if that's equal to 0, this now means that if I divide the roll by 2, if it has no remainder when you divide, meaning that it's divisible by 2 or even, that we are going to say we want evens to increment up by 1. Else, if that's not equal to 0, then it must have been an odd number, so I'd say odds increment up by 1. Then all we have to do is change these last couple, and we are set for today. So we are going to do, let's print the odds first. And just like that, we could have 100 dice rolls, and if I run this, right, we have 100 dice rolls. Now you could make it so there was more than just these two odd or even outcomes. You could make it so you could actually say, was it a 1, 2, 3, 4, 5, or 6? You'd have to do multiple if-thens. You don't even have to do an else. You could do if the roll is equal to 1, increment the ones up. You just have to have 6 variable placeholders then. Okay, so maybe to end with, I'll put a small piece in here, just about how to calculate probability if you wanted to, and then we'll wrap it up. Alright, so I took a second here to then introduce a new variable. I called it total. Within this definition, this function, I made that global as well, so we could use it inside and out. And then I just made this align with the if and else, and said no matter if it's even or odd, whatever it is, just increment that total up by 1. You're probably thinking you wanted to use trials, but remember, trials is a parameter. It was never defined as a variable, so it'd be tough to use that in a division like this. And we don't want to, reuse the word trials and have it be used for two separate things. So, but essentially the probability is just the amount that satisfy over the total events. So if I wanted evens, the probability of even would be however many evens we got divided by total. I printed both on that last one. So notice here 44 evens came out. That would be 44%. Obviously, you can take that amount and multiply it by 100 if you wanted it to come out to be an actual percent, and you could print the word percent after it or whatever you wanted to. So those are the basics. Hopefully that made sense, and don't forget to hit that like, hit that subscribe. Tomorrow we'll do something with probability. We'll see how it goes. and we welcome you back. Thanks for watching.